All right. I think we are live. I think I can see this. Let me paste it into a chat channel on Urbit. Alrighty. I don't intend to pay too much attention to the stream itself. I'm primarily just using this as a way to be able to concentrate and try to go through the exercise of explaining what I'm doing. Starting out with a little bit of a summary of what I have done here. If you do want context for naive rollups and how we're using them with Urbit and how they fit in with the general ecosystem for scaling for scaling Ethereum stuff, then you can look at the dev call that I did last week, I think a week ago today. I think if you just Google like Urbit dev call scaling or something, you should see it. And yeah, there I lay out everything up to basically why naive rollups seem like probably the best option for us, and what naive rollups are to some extent. Although watching this might give you a more mechanical understanding of what they look like. So right now I'm trying to build naive rollups, and there's various parts to that, particularly various different ways that it interacts with the rest of the system. The way, you gotta bridge be able to talk to it, you gotta have jail be able to talk to it, you gotta have all this stuff working. But I think but sort of the kernel of naive rollups is the state transition function, the azimuth rules specifically, the Urbit ID rules specifically. In the existing azimuth, those rules are written in Solidity. They're the azimuth and ecliptic smart contracts particularly are lay out the rules for Urbit ID. And so in this world, those rules will be sort of split. There will be the existing azimuth and ecliptic contracts, or maybe a slight modification of them. And then there will also be you will also be able to send batches of transactions on layer 1 that need to be read by layer 2. And so that part's new, but those batches are just batches of the old kinds of transactions. Anyways, what that means is that what we need to write to sort of fully specify the state transition function is we need to have the existing Solidity contracts, which we have, and then we need to have in Hoon a function whose input is either something that happened on layer 1, something that happened in Solidity, or a batch of transactions, and which produces a state. And so this whole, which ended up being a map of ship name to the specific state for each point. For each point is a term we use for ship in Azimuth. It's kind of an old term, but it's what's used in the Solidity, so I duplicate that here. And so this function is sort of an executable specification of how Azimuth works. Now, obviously, you could do a specification that's not executable and then do an implementation of that, but that's less precise. And in fact, we're going to need to be able to execute this anyways. So it makes sense to do it as an executable specification, just like a Solidity contract is an executable specification of a state transition function on layer 1 Ethereum. Anyways, all that to say, we need a well specified function that processes transactions sent by users, and rolls that up into a state. And so you could do that in various languages. We're going to do that in Hoon because it's Nock in particular is highly specified, and so meaning that it's precisely specified, and so we can whatever we write in this, it will not be open to interpretation, which means any bugs will be our own. So hopefully we can keep the code as small and simple as possible to avoid as many of those as possible. Okay. So I've done some work on this. It's a couple hundred lines here that lay out some of the structure. I'll try and go through it a little bit just to review for my own sake how this is going to work from a mechanical standpoint. Okay, so there's structure-wise, we have a few cores that for helper functions, and then we have the actual state transition function. And it's a function so it takes your new input and some state. I'm going to open this here as well, so we can keep the types up here. Let's take input and current state, and it's going to produce a new state. It's also going to produce a list of changes that happened. Which is primarily for convenience. You could define this to not have that. If you did, then jail, when it's trying to keep track of who owns what, would need to basically run a diff on the old state with the new state, which is doable. You'd probably want to insert you want to modify it to not just be a normal map, but actually you could probably do it as a normal map, and then have a specific equality type function on it, like doing a map difference. Yeah, you'd want to do a map difference function that knows basically that if it hasn't changed, it's probably going to be pointer identical, and so that's going to be cheap. Yeah, that would probably be doable, but I think it makes just as much sense to spit out a list of effects where these effects are not literally everything has changed. If you need literally everything has changed, just look at the difference in the state. But it's those things which are sort of the actual data, not the metadata, right? So diff point in jail is just these three things, right? It's either we breached, we changed our keys, we changed our sponsor. It doesn't have, we set our spawn proxy, or even that we spawned a ship, or that we transferred a ship from one person to another. The only things that it includes are those things which Urbit OS actually cares about, which is what are your networking keys, as opposed to your like ownership keys. You don't care about those. We only care about what are your networking keys, when are you breaching, and who's your sponsor. So we're going to return a list of those plus a new copy of our state with some, whatever modifications came from that input. So that means the two things we should look at is what is our state and what is our input. Our input, as I might have alluded to, is can be two different things. It could be a log that comes from the layer 1 contracts. So in Ethereum, when you're writing Solidity, you can, when something happens, you can emit a log, which sometimes is called an event. I'll use the terms interchangeably, although it's actually quite similar to what I've been calling an effect here. Oh well, they're all the same. Not the same, but similar. And those are conveniently indexed, basically, and so it's easy for a client to get all of the logs associated with a certain contract or to filter them in various ways. And so I believe that actually is going to be enough information for us to build our state. I'm hoping that's the case. If it's not, then we'll have to make sort of synthetic logs and make that a part of the specification, which will suck, but is fine, really. So these are things that happened in the smart contracts, which means that their signature has been verified. This is not something that someone's submitting to see if it'll work. It has happened, and we're just reflecting that in our own state. The second thing is we can also get a batch, and a batch is just represented as an atom. It's just a big long number, which is just going to be a bunch of transactions concatenated, and these are submitted. This is what naive rollups are, right? They're submitted as one big batch in a single Ethereum transaction on chain. And the transactions themselves might come from various different people. So each transaction comes with its own signature. And so these are not trusted. These are ones where we need to, check and see if the signature validates. And if it does, make sure that, the address that it validates to owns that ship, and make sure that the thing it's trying to do is real. I mean, you also have to make sure that the whole thing actually parses, right? Because this could be literally anything, or literally any atom. And so, well, I mean, it can't be huge because there's a block gas limit in Ethereum, but it can be any number up to, 2 to the, 100,000. And so we need to be able to handle those as well. Those are untrusted, need to verify their signatures. The way we're going to end up... Yeah, okay, so that's at a high level what the input is. The other, part of the interface is the state, which I think we can get away with just having one thing, which is a map of ship name to point state. Might end up having to have a couple of other small things, but that should basically be it. So for each ship name, we need to keep track of a few things. I'm using an existing type here. Since this function probably won't have access to the standard library, we'll need to implement that type directly in here. But for the moment, I'm just referring to a type that we use in our standard library, specifically this type. And so the important things here are the ownership address, management proxy, voting proxy, transfer proxy, spawn proxy. And then these are, sort of the data. If the other stuff's the metadata, this is the data. This is our key revision number, our keys, continuity number, so how many times we've breached, our current sponsor, or more specifically, the sponsor that we hope to have, and then whether or not we actually have it. These work together to allow basically double opt-in on sponsorship. I really think that this is the wrong, that it's a little bit overkill to be like, well, okay, this is our current sponsor, this is who we want to be our sponsor. Well, I don't know, maybe we'll have to come back to that. Ideally, you would just say, well, this is who I want the sponsor to be. And then if they say they're willing to sponsor you, then you're good. Although notably, that other piece of information actually isn't in here. From the perspective of the parent, there's no list of ones that they sponsor. And so that's something that needs to be stored somewhere. The problem if you store this just as, an intended sponsor and then check and see if the other side agrees to it, is that when you want to change sponsors, you then have no sponsor until they accept you, which is not a great experience. We'll have to think through that. Okay. Then, but the important point is that our state overall is a map of ship name to that, plus one more piece of information, which is new, I'm calling it Dominion for the moment, which is basically says, the way I'm thinking of it now, actually, it'd be better to say, like, basically this is L1 versus L2 versus spawnable on L1. Call it L1.5. So this records basically whether this is a ship that is controlled in the Solidity smart contracts on L1 or here on L2. If it's controlled by L1, then the only way for it to change is through log inputs. If it's on L2, the only way for it to change is through batches. I think there should also be a somewhat intermediate state where it's still owned on L1, but the spawn proxy has been set to here. And in that case, you would be able to do everything on layer 1, except you wouldn't be able to spawn on layer 1. And then on layer 2, the only thing you could do is you could spawn ships. And that, I don't know, that seems like a useful compromise for... we'll have to see how much complexity it adds, but if it doesn't add too much complexity, then I think it'll be worth it. Okay, so then that about covers what our state is. And we should start looking at the code. Should we go through batches first or logs? We should probably go through logs first because they're simpler. So we get our input. It's either going to be, and this is not super well organized, but it's either going to be a log, which means it's trusted from layer 1, or a batch. If it's a log, then we interpret it. And so we can check what kind of event it is, what kind of log it is. Logs have, the way they're structured is they have a series of topics that you can filter them by. So there's 4 32-byte topics, just byte strings. And that's traditionally done as the name of the event in its in this sort of signature, like standard signature type thing. So the name of the event is transfer, and it has 3 arguments: address, and uint256 are the types there. And so we hash that, and that gives us the 32 byte topic like name basically, and we're gonna check whether that matches the first topic in the log. Because this hash is, it's a hash of a constant, we use ketsig to run this at compile time. Ketsig will check and see if it can run something at compile time, and if it can, then it will. In this case, obviously, it will be able to because it's a constant. I also tested this in the terminal to make sure that it actually does, and it does. So I think this is easier to read than putting just a blob of hex digits in there. Right, so I have not implemented all of the logs, definitely, but I've implemented a few of them. In particular, this is the transfer log. When we see transfer, what we need to do to our state is basically say, oh, okay, that ship was sent from one person to another, so the ownership address has changed. It's possible the other stuff has also changed. There's a way to transfer that resets your proxies and your networking keys. But if that happens, those will come in separate events. So we only need to handle the fact that the ownership key has changed. So we parse those out of the topics. So that's, so i.topics is the name of the event. I.t is this first address, so it's the from address. I.t.t is the to address. The last one's the ship itself, which is here. Notably, yeah, this is in data when it should be in. It should be i.t.t.topics. There's a pull request open to change this in the Solidity, which I think is a good idea. It's gotten set aside, not set aside. It's more just I haven't had time to actually deploy the new contracts and then start a Galaxy vote to make that tiny little upgrade. The main reason it needs to change, or that should change, is because ERC 721 dictates that it be in the topics and not in the data. And so this is why if you go into Etherscan and you look at an azimuth transaction, it looks like you transferred a bunch of tokens, because when this is in the data section and not in the topics section, it looks like an ERC20 transaction. In an ERC20 transaction, that's how many tokens were transferred, whereas in an ERC 721 transaction, that's the ID of the token which was transferred. And so Etherscan interprets it as an ERC20 because we actually don't quite follow the ERC 721 standard in that case. So for the moment, we do it this way. When that change goes through, we're going to want to change this, which means that we'll actually need a rule in here that says something like, so I think we're going to need a block number input as part of the input as well. And then we're going to need a rule in here that says basically before this block number, look in data, but after this block number, look in i.t.t.topics. There's another T in there. But regardless, that's how we parse the data from the log. And then we say, okay, let's see what state we have about this ship, if any. First, we want to assert that it's not ours. I'm actually not going to change these yet because I'd have to change them everywhere. So no means it's on layer 1. Own means it's here. It's on layer 2. So we need to assert that that it's not on layer 2. Because if it were on layer 2, we shouldn't be getting logs from layer 1 about it. That would be bad. In general, error-wise, we shouldn't crash here. We should, whenever there's something that doesn't work right, we should treat it as a no-op. However, two things. One, it might be better to write it as a crash and then up at the top just virtualize the whole thing. And if it crashes, turn that into a no-op. That's probably best, just for debugging purposes, because you can get a stack trace. But the second thing is that there's a difference between things that we want to be true, or that we are asserting are true, because if they're not, we want to no-op. So, for example, if a signature fails to validate, that means we just want to reject this transaction. If this happens, that means that there is a bug somewhere. There's a bug either here or in or on the solidity side. And in that case, maybe we do want to just crash, because we don't want to keep going forward when we know that there's a bug. We would want basically for everyone to agree on a way to solve that bug. In like for people who've developed on Ethereum, you're probably wary of being super aggressive about assertions that say, hey, if there's a bug, just crash and stop, potentially even stop the contract from moving forward. Because if you do that on Ethereum, then all your assets are locked in there essentially, and there's no real recourse. Or at least there's no in-band recourse. And for us, that's also true on some level, right? There's no recourse in band, but if something like this crashes, we all have all the state up to there. We all agreed that it crashed in the same place, and then there just needs to be some kind of essentially community decision about how to go forward, about how to modify the spec such that you can keep going forward. And so that's something that sort of traditionally the galaxies will tend to vote on a decision like that. But of course, ultimately the galaxies are more of a conduit for power than the actual source of it, because if the galaxies vote themselves supreme powers or whatever, then users will just fork Azimuth and use their own. And so the galaxies are more of just a convenient mechanism for basically giving legitimacy to certain proposals, because they're people who are involved in, who care a lot about the system, have a significant stake in the system, and if they agree on something, then that carries weight. Similar to how if the Geth developers agree on something, especially in combination with the with the other Ethereum node developers, that carries a lot of weight, even though and the exchanges have their own things that where they they may have their own opinions, and what they say matters somewhat. The developers of, say, MetaMask and other wallets, that matters somewhat. The opinion of miners matters somewhat, but ultimately the value goes to wherever users believe that it should, like wherever they end up choosing. It's also honestly exactly the same thing as what do you call open source projects. If OpenOffice worked great for a long time, and then when the user base, or significant parts of the user base, lost faith in their new ownership, when they were when Oracle took over, basically, then they just made their own LibreOffice, because anything that's open source, anything that's a protocol, is ultimately just people are going to use whatever they want to use, which doesn't mean that governance structures don't matter. It's just that the open source governance, or governance over protocols, is fundamentally different from what we usually call governance, because it can't actually coerce you to do anything. All it can do is it's just a mechanism for getting people to agree, usually in something that has network effects, where it's beneficial for people to agree, right? It's beneficial for there to be not too many forks of OpenOffice so that they can all talk to each other. It's beneficial for there to be not too many forks of Ethereum. But if there's enough of a disagreement, then there will be a fork, and that's true of Azimuth as well. And so what we do, and so we have, we're subject to the same thing. And so if we end up in a situation where, due to some bug somewhere, this statement happens to be false, then really we need, sort of divine intervention by the consensus. And yeah, so I'm comfortable with that for now. This is all still fairly rough code anyways, and I'm sure we will revisit that decision. But enough of that tangent. So we parsed the transferred ship, who it's from and to. We say, okay, when a transfer happens, we don't produce any effects because ownership isn't something that Urbit OS cares about. We only care about keys, breaches, and sponsor. So no effects. The state has changed. Specifically, we modified transferred ship to have the new owner. Primarily, right, so the logic here is that the new owner... Okay, there's several things going on here. I'll actually go through this in order. So this here is that if the new owner is deposit address, which is this special address, we might choose, I don't know, a different address, but this is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 4 times. So it's just an address that has no, that nobody has the private key to. And we say, okay, if they transfer to that address, then we interpret that as switching from... This is not quite right. This is close though. We interpret that as saying it as a deposit to layer 2. Yeah, okay, so I think there's a couple bugs here. I haven't even actually tried to compile this code. So let's try and tighten this up a little bit. So if we're depositing it to that address, then now we're saying it's owned by layer 2. That's correct. If we're not depositing it to that address, that doesn't mean it's not owned by layer 2. It's possible that it might be... like, we know that it's not... we know that it's not owned, but it could be that we have spawn rights for it. That layer 2 has spawn rights for it. So what this should be is basically, if there's no existing state, then it's no. Otherwise, there is an existing state. Existing state is going to be one of these, and so it's dominion.u.existing state, which could be no or spawn. I really don't like these names. I'm going to change them to to L1 and own Yeah. I'll leave spawn for now. You could call it S2. But spawn is fine. Right. Okay, so sort of implicit in this is that this map starts out as an empty map. You could start it out as a map of 4 billion ships with empty point states, but it's going to be more efficient to start it as just an empty map, and then over time you add things to it, and so you can't assume that it exists already. But if it doesn't exist, then it implicitly it has, like, anything that doesn't exist we interpret as this. So just the bunch of azimuth types, and it's on layer 1 because everything starts on layer 1 effectively. Although, okay, that's actually not quite true. If the parent is, so if it doesn't exist in points and the parent is either on layer 2 or can spawn on layer 2, then we consider that ship, the child, to start out on layer 2. Otherwise, but either way, it starts with with a blank set of ownership addresses and keys and all that. Okay, so much for that. Then I think this is not going to be necessary because I think we're actually going to just process everything, all the logs from L1. Okay, so then the slush point is a little bit of a less common syntax. It means basically run this, and then from this take owner.own and replace it with from. It's equivalent to saying tisfas this, and then this. Or if you want to be even more, I mean, like that's what it's doing. I like this style slightly better for this case, but a lot of people write it this way, and that's fine. Right, so we're saying we start with if it doesn't exist in here, then we start with just the bunt of the type. Otherwise, use that. And then, right, so that's our before state. And then we just set owner.own to from. I really think that this type should be flatter. It should just be one big buckle. But this is the one that exists now, and I don't know, maybe I'll change it when we move it in here. But for the moment, I'll just not think about that. So we changed the ownership address. That's all. That's all that goes into. I mean, that's all that transfer means. It's not that complicated. So then, next log is if we change the spawn proxy. And this has two arguments, a uint32. So in the transfer one, we do a uint256 because that's what ERC721 dictates. This is our own one. Obviously, ERC721 doesn't have any concept of a spawn proxy. And so we use uint32 because the planets are 32 bits, slightly cheaper on Ethereum, and it communicates the intent better. And so uint32, so it's saying that this ship it has set its spawn proxy to this address. And so, whoops, yeah, we expect 2 topics. First one, there's 2 more topics. First one is the ship. Like I said, that's who we're setting the spawn proxy to. We do the same deal, except that here, yeah, this is the same. We say we need to not already be. Actually, this is incorrect. It should be the it should be either that it doesn't exist or that it exists and is on L1. Right. If it doesn't exist, so the reason why this is wrong is that, which is what it was before, is that if it's already set to spawn proxy, then we shouldn't be able to hear that it changed its spawn proxy, because once you set your spawn proxy to the rollup, you can't change it back. If you do, like if you were to be able to, then you would be able to spawn that's a good point. It needs to be written here. You would be able to potentially, if your spawn proxy is set to the naive rollup, and then you start spawning ships on the naive rollup, you'd be able to go onto the main chain and start spawning ships on the main chain, and that's no good because you can spawn the same ship in 2 places, and that will probably make this crash somewhere. But more importantly, you've just duplicated a planet. That needs to go on this list as enforce that once spawn proxy is set to deposit address, you can't spawn children. Yeah, these are changes that we're going to need to make to the Solidity contracts. They're all quite small. They're similar to the one we just added. Okay. Right. So once we get past that assertion, then we say, okay, then we're going to update this ship in our state, and we start with this. Right. So either doesn't exist, in which case bunt it, otherwise use it. And then we say, okay, if we're setting the spawn proxy, or if we are not setting the spawn proxy, then that's what we leave. Sorry, if we're setting the spawn proxy to something other than us, then that means they're just setting the spawn proxy on layer 1. It has nothing to do with us. And so we're just going to reflect that information here. We're going to say, okay, well then L1, that's a bug. Let me explain this first. Right, so we set it to L1, and just update the spawn proxy. If it did get set to us, that means they're depositing the spawning rights to the rollup. And in that case, we want to produce, we want to set it so that we have spawning rights, and just produce the point itself without overwriting the spawn proxy. So the principle when you deposit to the rollup is that whoever deposited it has those rights on the rollup. Whatever address deposited it, that same private key has the same rights on the rollup. So transferring to the rollup doesn't mean that from address is now useless. It's what you use to control it on the rollup. And so we leave the spawn proxy the way it was, so that if you had a spawn proxy set and then you set spawn proxy now to the rollup, that address that you're using as a spawn proxy, you want to be able to continue spawning stuff. It's just now you'd spawn it on layer 2. So we don't want to overwrite that. So that's the issue here, is that we're overwriting it when we actually shouldn't be, I believe. Because we're overwriting it to potentially the wrong thing. So what needs to happen here, first of all, we're setting it to from, which is weird. What we want most of the time is to set it to 2. Except, basically, if we're in this case, I'm going to do this on one line. I think people really hate it when I do stuff like this, which is what you would have to do if you wanted multiple lines. So I will do it this way. I think it's clear enough anyways. So if we're depositing it, then the new ownership address is the from address. If we're not depositing it, the new ownership address is the to address. Does that make sense? Right. Like in the usual case, a transfer means the new ownership, the new owner is the to address. In the depositing case, that means that we are, I mean, and in fact, it probably actually, arguably it just shouldn't change. This should be equivalent to it just not changing. Right, like owner.own should be the same thing. Possibly we should assert that. I don't think we really need to, but yeah, I think this is the cleanest way to write it. Yeah, so whoever it's being transferred from becomes or continues to be the owner of it when you deposit it, because the only thing it's actually changing is layer 2. Is that we're switching it, yeah, to be owned by layer 2. This code is not the clearest. Definitely want to do a clarity pass at some point, but I think that's basically correct. Okay. There are more events that we need to handle. I haven't written any more code for that, but mainly it's things like change management proxy, change transfer proxy. Those are not like they're going to look like this, except they don't have to worry about depositing, because you can't deposit your voting rights or whatever. It'll just update the state is all. So these are the interesting ones. The other ones need to be done, but that's busy work, which we'll do after we look at the other case. So that was all looking at how to reflect things that happen in Ethereum inside the rollup. The other thing that we're going to want to do is handle batches. So with naive rollups, you send a batch of transactions. And this should really all be in a helper function, so that this main function can be clean. Let me just do that real quick. Let me look structurally. Should this be down here, or kind of want it up here? I'll have basically a whole core for this stuff, I think, because I don't know. I'll rearrange it later if I want to. Process log. I don't use that name somewhere, right? No. Okay. And so that's going to be this. Process log. Event log dot input. And that, of course, helps with these really long variable names. Cool. And this, of course, needs to produce the main, just this, right? This also needs state. I'll pass it in right now. Arguably, I don't know. There's a few different ways to arrange this. This will be fine for now. At least keep it separate. Cool. Okay. Then now our main function is cleaner. Yeah. Probably want. Right. So either we received a log from the L1 transaction, or we received batch. And so in that case, we want to. Oh, that comment is meant as a to do. We're gonna need something that okay, what's input? So we need some function that looks like that, which doesn't exist yet, which is going to give us a list of transactions. I'm not sure what's the best way to make that list. Actually, you could do it as, in fact, it's probably best to do it sort of a piece at a time, or which is fine. Actually, we can do this. Yeah, a split batch function. What it'll probably do is look at each transaction. Yeah, so there's a few issues here. What you want to do basically is read the first byte or whatever and say that's your opcode, and that tells you how long the transaction is, and then there's a signature after that, which is always 65 bytes. If you do that, then if anyone submits, because remember this blob, we don't trust anything about this blob, and so if someone submits a malformed transaction that's shorter or longer than it needs to be, then all of the other transactions are going to fail. Well, they're going to be read at, like, they're going to be interpreted wrongly, which should mean that they'll fail because they're all signed, and so the signatures will fail. That I think is fine. That means that an aggregator needs to. It doesn't need to verify that a transaction will succeed, but it does need to verify that it's well formed. It needs to verify that if it's an opcode 1, then it takes 20 bytes or whatever it is. Because if it doesn't do that, then the other transactions in the batch, all later transactions, will fail. Okay. So if that's the case, I still sort of feel like this actually shouldn't be done separately, that we should do this one step at a time, like one transaction at a time, so that if you get to a point where it fails, you can just abort there, rather than if you parse it all first, if any of them fail, then do you just abort the whole batch? I mean, that might be a good thing in itself. It's hard to say. Maybe you should abort the whole batch. I'll write it this way for now. Because it's, marginally easier to think about. But we'll want to revisit that. Okay, so then once you split this up into individual transactions, for an individual transaction, first thing you want to do before you do anything is verify the transaction signature. And so that I have implemented. So the way that I'm writing transactions right now, let's see, is that we take the first first byte, basically. So we have a block system in Urbit, which means that 3 represents 2 to the 3, which is 8 bits, which is 1 byte. So that 3 means we're taking a byte, then we take 32 bytes, 32 more bytes. That gives us our VRS, which we then pass into an EGTA verifier with TX data and make sure that it validates. So when we do this, so take goes says basically take the first part and then produce the rest. So we're mutating, with air quotes, TX data as we go along. That way we don't accidentally be like, okay, take the first through fifth and then fifth through seventh. Oh, you double counted the fifth one. Take with mutation, I think, is sort of a clearer way to write that. And so then what's left is the transaction itself. So note that this assumes that you've already determined where the end of the transaction is, because it just takes all the rest of it and runs that through the verifier. The verifier, what it does specifically is you can get an address out of that. Something looks like a public key, and then we can convert that to an Ethereum address. So what verified transaction gives us is the signer address, and then we can use that to check basically where that signer address matches their owner address or management address or whatever we end up needing for that action. So Verify TX doesn't verify that they can do that transaction. It verifies only that it's been signed by a particular address, that the signature is valid, and then we can later on check and see whether that address can do this stuff. Okay, so once we've done that, we run parse TX, which this is going to be an important format to specify as well, of course. Which is just the transaction format in those batches. We want this to be quite small because every byte here costs 16 gas, which isn't that much, but the way it's written right now, we end up with something like 80, 90-ish bytes, which ends up being about 1,500 gas. And so 1,500 gas is much cheaper than the 150,000 or whatever that we're doing now for each transaction. Some of them are over 200,000. I think I've seen some at up to 300,000 gas. But still, 1,500 gas is not nothing, and you want to save as much as you can. So we're not going to be like jamming or doing anything like that here. So that's not quite right. You can tell I haven't tried to compile any of this stuff. Right. So we're given this transaction data, which is, note that we produced it here. So we've already got rid of the signature. We've already stripped the signature off the front of it. And so now we want to parse the opcode. So remember, take the first argument is the block size. So 2 to the 0 is 1. So this is talking about 1 bit at a time. So 7 bits. So the first 7 bits are opcodes. I think 7 bits is enough. It's 128 options. There are something like 30 operations right now. And so you could probably get away with 5 bits, but I think 7 is fine. The reason I do 7 instead of 8 is because a decent number of our functions take a Boolean argument. And so we should, and this is where the bug's at. We shouldn't take 7 bits for the Boolean. If we only reserve 7 bytes for the op, then we can 7 bits for the opcode, then we can within that first byte. I know there's no real reason to byte align this stuff, but it feels nice. You can just take that last bit and make that be the Boolean argument. Right, so we got one more bit. That gives us this. Note that I've been saying Boolean because it's Boolean in the solidity, but as written here, it would be Lubian. That's certainly something that we need to, that needs to go into the specification. I kind of tend to think that it should be, that it's like, well, if this is all being written in Hoon, we should do it as Lubians, where 0 is true and 1 is false. But certainly something to pay attention to. Right. So the way we're parsing this, by the way, we're parsing this into a TX structure. Obviously, there's a bunch more functions here that should be implemented. I just have 2 of them that I've written out so far. So if opcode 0, we interpret that as transfer point. Then we say, okay, the first bit after the opcode is this reset flag, which exists in the solidity and says, in fact, let me bring up the solidity. Transfer point. So this is written as, this is much wider. Right, so ship name, target, and then reset. Reset resets your, the proxies and networking keys at the moment of transfer, which is meant to be used if you're transferring to a new person, so that the old permissions shouldn't apply. That doesn't strictly need to exist, and maybe we should make it simpler by not including that. But for the moment, I'm erring strongly toward just duplicating the functionality that's in Solidity, so that we can mostly think about mechanically how to implement this stuff, and not so much about what's the prettiest specification. Right. So then we parse 4 bytes for the ship, because the ship could be up to a planet, which would be 4 bytes. Obviously, something like that could be written as 5.1. I think it's clearer to write it as 4 bytes. 5 would be 2 to the 32, so 32-bit word, which would be 1 ship. And then address. Lots of rollup systems like to use pre-registered addresses so that you can use fewer bits here. But in the spirit of doing things as simple as possible, I think we should just do this as the full address written out, like you would see it on an Ethereum transaction. Those are 40 hex digits, which is 20 bytes. And so that's the next 20, which means that overall the transaction data here is 25 bytes. Plus, obviously, the signature, which is another 65, and so that's where you get to 90 bytes. And then we assert that we're done, that we're out of transaction data. If it's longer than that, that something went wrong. That's the sort of assertion, though, that should not be a true crash, right? That one should just be a no-op. If you even if your transaction signature, if the signature verified, but the thing didn't parse, then it's just a no-op, is what it should be. Right, so then another transaction that I have implemented here is spawning. It doesn't have any flags, and so we just take the first bit and throw it away. And then we say, okay, we spawn a particular ship to a particular address. Also going to be 25 bytes of data. the other functions will be basically all the public functions here. Like there's spawn. Well, they'll need to be configured keys. That'll need to take in, a bit more data definitely, because bytes 32 is 32 bytes. That ends up being what, 64 and 8 plus a flag, but the flag is free basically. And so that's like 76 bytes, which is significantly more, but 65 bytes of transaction data, of signature, it's not that much, right? Right. So those will only need to be implemented, but for the moment, that parses the transaction into something that looks like this. And we can go back to the call side of parsetx and say, okay, now that we parse that, now we just fan them out into the different, to different handling for each one. We're almost done with what's here. So if we parsed out a transfer point one, then we call process transfer point, and this is going to look, it's worth putting these up probably next to each other because it's going to look the same. This part's new for us, right? First thing we want to do is fetch what information we have about this point, about the ship. Make sure that it's on layer 2. If it's not on layer 2, then batches can't talk about it, and so that should just be over. And of course, that's the sort of assertion that shouldn't crash the whole thing. This should just turn into a no-op. And so I feel like we are going to want to virtualize the whole thing to interpret crashes as no-ops. Or possibly just virtualize each transaction at a time. That's probably the right thing to do, actually. Okay, then... Right, so then we know that we have control over it. So now we want to just basically do this stuff, right? We want to say, out of the point state that we got, we want to say, that we want to assert what is here is a helper function that's azimuth.can transfer. The content of that function is that either we are the owner, where we being the signer address, which comes in here because it's defined before the barcat. And so either the signer address is the owner or is the transfer proxy. If it's one of those, then we can keep going. And so then active is, in my opinion, a misfeature, and we should probably ignore it because it doesn't make a lot of sense and isn't used for anything important, certainly. And so we execute the actual transfer. Here we wrap that in saying check whether it actually changes, but that doesn't really matter for us. It matters for Ethereum because you can save some memory sometimes. Save some gas sometimes. So we say, okay, what was the old owner? But we only need that because we're going to emit that transfer event, which is you'll recognize as the one that we handle over there. And so we say, okay, azimuth.setOwner, point to target. That's this, basically. We say set the new owner to the to address, which is called target over there. And we set the transfer proxy to null. Apparently, ERC 721 says that every time you transfer, that has to get reset. So we do that. And then obviously that needs to be put back into points.state, which it is down there. Yeah. Okay. So then next thing we do is notice this is not an if else. This is just an if. And then we say if the reset flag was set, then what we're doing here in the solidity is we say, again, I think has been linked is a bit of a It's well, it is precisely defined, but it's not a very helpful definition. It's better to just operate on the data directly, in my opinion. But what it mainly does is it increments the continuity number. So if we're saying we want to reset, then we breach basically, and breach it to have new keys that are null. Notice set keys will increment your life number, which is your key revision number as well. It's not written here, but it will. And then we clear the management proxy, clear the voting proxy, clear the transfer proxy, which will likely already have been done, but it's possible that it's not, at least in the Solidity. Maybe not here, but in the Solidity it is. Clear the spawn proxy, clear any claims, which is a layer 1 concept that we're not going to, probably aren't going to support. Maybe we will need to, actually, because yeah, we should support that in some way. But that's going to need to be sort of built on top of this, and should probably be triaged out of the initial run. Yeah, we'll skip that for now, but worth thinking about. And so that here is just saying, okay, well, if we didn't reset, then we're done. We're not done. Another bug there, right? What that was going to do is we updated point, but point is just something in our subject here. You need to reinstall that back in state. We should probably actually, what we should do is this, and then it'll need to happen again here. That's I don't know if I've ever quite seen that pattern, and so I should write a comment saying basically save point now, but we might overwrite later, right? Because we're going to modify point in this case. If you put it here, the problem is that it looks like it's not, like if you end up putting in another branch somewhere, you might not end up saving it. It's very important to make sure you save it. And it's okay to save twice because, I mean, it's fine. Okay, then if we are going to reset, then we want to, and then this is basically a translation of has been linked. So we say if we've set our keys effectively, then we want to set, so everything net.point is sort of the data, right? So we increment a life number, increment the continuity number. That 0 there is the crypto revision number, which we set to 0, and you can set it to whatever you need it to be in configure keys. But we're clearing this, and so we want to set that to 0 because we're clearing the keys, right? And then sponsor escape. What about our own keys? Oh, sorry, that 0, I'm misleading you. That 0 is this, which is pass, which is the your networking keys. So we're setting the networking keys to 0, which is which obviously corresponds to these zeros. Okay. And then sponsor and escape stuff does not change when you transfer, even when you hit reset. It doesn't like clear your sponsor. Okay, then we also set the ownership address to own.point. Or specifically, sorry, we don't change own.point, but we do change. You can tell I haven't actually compiled this because that's not going to compile. It's owner.own.point. So we leave owner.owner.point, but we clear the other ones. We clear the management proxy, voting proxy, and transfer proxy. We need to clear the spawn proxy as well, right? Yeah. So that needs to be what? I have a to-do somewhere else that says basically this should not be a unit. It's a real pain for it to be a unit, so I'm going to assume that it's not a unit and say it's spawn proxy.kid dot point. Tis dot that to tar address. So right, so clear that as well. And then we save our new point, and we're done. That basically matches what's here as well. So then we'll look through. So, so much for transfer point. Then spawn is going to be the next one. Okay, so spawn, we run process spawn, which I have named that wrong. Process spawn. This, our template is here. It takes the ship that you're spawning and the target. And so when you're spawning, obviously there's the parent and the child. First thing we do is you say, okay, this is our parent, which is the equivalent of this. Note that this is parent in the, like this is, sort of biological parent, if you will. Meaning that it's not your sponsor, it's just your prefix. And so that's the function for that is ket sane instead of just sane. And it doesn't need your, our and now or anything because it's just a prefix function. So we get our prefix parent, and that one we need to get what we know about that and make sure that it's either it's either stored on layer 2, or sorry, we either have full control over it here on layer 2, or at least we can spawn from it. So if we can spawn from the parent, then we can move forward. And so then we say, okay, the parent point structure here, we want to make sure that we can spawn from it. So we know this transaction was signed by signer. So if the signer is either the owner or that's a good assertion. We have that assertion down here. Okay, yeah. Right, so it's either the owner or I don't know where this assertion happens down here. It's this one, I think. But yeah, he's right. So either we're the owner or we are the spawn proxy. This is written assuming that kid stays as a unit, but I don't think it should. One of the reasons why is because it makes this simpler, right? That's a much better way to write that. Makes the intent much clearer. And so we say, okay, owner.own.parent, signer, spawn proxy.kid.parent, signer. If one of those is true, then we have the permissions from that perspective to do it. We do need to make sure this ship has not been spawned. That I believe that to-do is correct, but I would want to make sure, I'm nearly positive, but I want to make for certain sure at some point that when you run spawn here, it should result in a transfer. Yeah, it results in a transfer event in both of these branches. So I believe that's true. I'll leave the two to do in for now, but I believe that's true. That basically if it's not in our state, points.state, then that means it hasn't been spawned yet, and so we can just and so that satisfies this assertion. Next assertion is that you're spawning something that is one level down. So galaxies can spawn stars, stars can spawn planets. This is the one that some people really don't like this assertion, because they're like, galaxies should be able to spawn 65,000 planets. And maybe that's true. The advantage of hewing close to the existing spec is that you can just plead that this is how it is right now, and the point here is to switch to naive rollups, not to fix the spec. So we're gonna just duplicate what's here. Get point size. Let me make sure that is implemented how that's pretty simple. If it's less than 1 hex 100, then is 0. Less than 1 hex 10,000, then it's 1. Otherwise it's 2. That should work fine. Parent plus 1 is that. Okay. Then and this matches the structure of spawn over here. We check and see whether we're spawning to ourselves. This might be overcomplicated, and possibly we should simplify this, but the way that it works right now is we say if we're spawning to ourselves, so this is actually probably kind of a reasonable thing to do. The rule is if you're spawning to yourself, then we could just directly do the spawn. If you're spawning to somebody else, then what we actually do is spawn it to ourself, I believe, and then ourself with an asterisk, and then set the transfer proxy to the other person, and so that they can go. Like the way this looks like in Bridge is it looks like you have an incoming transfer that you need to accept, right? So it's this two-step like double opt-in transfer, which is a good pattern that we like to use because it makes sure that you don't accidentally send something to someone who, to the wrong address that has like, a typo or something, because it only actually gets sent when they accept it. It's a good pattern. It's a little bit more expensive for various things, which sucks on Ethereum, on layer 1 right now. But it's certainly at least be an option, because if you're sending valuable stuff around, it's worth spending transaction fees to not have to worry about that. Okay. So those are the two different cases. This goes into do spawn, which is pretty small. So the ship, the two addresses are the same, and then it's a question of whether it's direct and who's going to be the holder. So if this doesn't really need to be a separate function, I don't think, unless there's something else that calls it. There might be. Create Galaxy calls it, but Create Galaxy isn't needed anymore because all the galaxies have been created. Although it should probably still exist in the Solidity for so that you can kind of do unit tests, and also if you want to deploy it to like Ropsten or something. But what I will put here, that it doesn't need to be separate. there's only one place that we branch, and it's right there, and so that branch should just go up here. Okay, but what it's doing is it says, and note that the owner, the holder is going to be not necessarily the person who sent the transaction, but the owner of the parent. So the spawn proxy of the parent might be spawning this ship, but it goes, when we're using this withdraw pattern, this two-step pattern, we spawn it to the owner, not the spawn proxy. And from there, set the transfer proxy to the other side, which isn't going to make a difference unless for some reason you need to pull that back, either because they can't accept it or because they choose not to and you decide to pull it back for whatever reason. And in that case, you'll need the ownership address. That seems correct to me because you don't want to take something like a spawn proxy. So the security characteristics of a spawn proxy are, you want to keep it from other people because they could spawn your assets with it. But you don't mind if you lose it particularly, because you can always go back to the ownership key and regenerate the spawn proxy. And so with spawn proxy, like with an ownership key, you have to balance keeping a lot of copies of this in various places so that you don't lose it on the one hand, and on the other hand, keeping as few copies and as hard to get to as possible so that someone doesn't steal it from you. With a spawn proxy, you mostly you keep it somewhere for easier access, and so you don't have to access the ownership key, but you don't mind if you lose it. If you are unable to keep it secure for some period of time, just burn it. If it's on paper, you can literally burn it. Otherwise, just like erase it or whatever. And you can always regenerate it if you need to later on. So, given those security properties, you don't want to have Azimuth, be putting assets at that address, which might get lost for whatever reason. So we put it at the closest ownership address, basically, and that seems like the right decision. Okay, so then the actual spawning is, of course, pretty simple. We just install into points.state at that ship name. If it's direct transfer, we just set the owner name or owner address and don't do anything else. This is a syntax error. It's that. This is the more common way that you'll see Centaur used, which is to say, basically, that was weird. Yeah, that's what it should be. Which is to use it to say, okay, I'm going to bunt something or have some potentially complex Hoon expression here, and then modify the result. And so we say, okay, bunt this, and then in that result, do set the owner to 2. If it's not direct, then we want to set the ownership address to holder, and we want to set the transfer proxy to the 2 address. Yeah, and then just produce that. And that leaves us in a good state. Okay, so that covers, I think, all of this code. One quick note back on verified transaction is that this is a crypto function that is fairly complex and uses a significant part of the standard library. And we generally want to reduce the dependencies involved in this function. Like we're not going to include, usually the Hoon compiler is in every subject, right? We're not going to include that in this subject because this is going to be a specification, and so we want it to be as small as possible. And things in Hoon.Hoon change, things in Zeus change, and this can't change very often. And so we want to keep its we want to keep its definition as small as possible. And so what I think we should probably do to make this clean is instead of just pulling the function out of our subject, define it as part of your input. So it would be in our main function, say, here we have a verifier, which is just going to be a, wherever it went. This, which is good. Yeah. So it's going to be this. And then it's going to produce a public key, right? And so if you take that in as an argument, then in your specification for how this rollup works, you can say, you already have to specify things like, okay, this is the format of your input, right? This is the format of a batch, and so you'd also specify. Right, and you also specify this is how you execute knock, which is just the knock spec, and then you also specify that each input should come with a verifier, and that verifier just needs to be a standard EGTA SecP256K1 verifier, and that is like something you really need from a spec is that it's precise. That I believe is a precise specification. And so what this does is it says if, in fact, I think I might just go ahead and do this. What it says is if we wrote in some bug in the knock for either in the standard library that this uses or the crypto code there, ignore this knock. What matters is the specification. And in fact, of course, the knock is executed by jets, which are going to be more authoritative than our knock implementation, right? We don't actually want to implement our own crypto. And so we implement something that we believe is correct, but then actually run it with jets, which the jets are just a standard C implementation of this stuff that we didn't write ourselves, right? And so if you take that in as an argument, then if you had a bug in your knock, you can just fix it without having to get consensus about, oh, there was a bug that we have to fix, have to do a galaxy vote, we have to convince everyone to upgrade or whatever. You can just say, oh, there's an implementation bug. It's not a specification bug. It's just an implementation bug. You should, hear that the fix is coming in an OTA, and that will let you keep going forward. And so that gives kind of an easy default answer to what happens if, so there's basically two kinds of bugs that can happen with a verifier, right? One is that it accepts something it shouldn't, and the other is that it doesn't accept something that it should. If it doesn't accept something that it should, then an old transaction will look like it didn't happen when it actually, per the specification, did. And so you send an OTA, you just replay those transactions, and bam, everybody's up to date. It's clearly just an implementation bug. There's no consensus break there, although it will look like that for a period of time. If there's the other kind of bug where it accepts something that it shouldn't, then it's the same kind of thing, where it's like as long as someone notices that this was an issue, they will say, hey, everyone technically just ran the specification wrong, and so push out an update, rerun the events, and bam, you're back into something good. And so I think that this is a good pattern for sort of factoring out the few complex things that we need to include. Most everything we include from the standard library is bit manipulation, like take or whatever. Possibly Ketchik 256 should be there too. It's a hash function. I don't know if we use it for anything like security critical. It's right now it's just used for, or sorry, yeah, we do. The catch-check function, I believe, is inside this as well. Possibly verifier should actually include this as well. It's hard to say, but I'll just write it this way for now. I'll make that a type name. Yeah, probably it should include that as well, because we're not going to need the public key for anything else. Let me see what that looks like in the library. Here, address from pub, n3 of catch-check, and rev. That just flips it. That's that. So rev and end are both just bit manipulation. We can include those. That's fine. And then it just depends on if we end up including catch-check here, then we should just include this as well. If we don't, then we shouldn't. I don't know. I'll write it this way for now. Cool. Okay. So that's what's there already. Now I got to think about basically what's the right way to move forward. So I think that other than a few to-dos here and there, it is mostly just fill in all the more logs and all the more batch functions, which is mostly a lot of grunt work. But grunt work that has to be exactly right. Okay, then refactor this slightly to be nah, it's fine. Some people like this as a bar cat, and then it would be a series of what calls anyways, and then it'd be slush, process, transfer, process, whatever. It doesn't really make it any cleaner. I think it's fine to do it this way for now. The one thing that it would do is it gives you a place where you can see. It might be worth it to have a place where you can just see all the different logs that it's going to process. I'll leave it the way it is for now, but that's might go the other way later. Grunt work is always easier when you have an endpoint, when you have a list of all the things you need to do. So that's probably the right thing to do right now is fill out the types of logs that we're going to handle and of batch transactions, and then we can just go through and fill them in. Okay, so for the logs that we're going to handle, that I would just do here as another series of what calls. Okay, so the events that we're going to look at are actually probably going to be the ones in azimuth. So in the solidity, it's split into ecliptic and azimuth. Ecliptic is what you write to. Azimuth is usually what you read from because that's where the data is stored. Ecliptic is the automatically upgradable part, and azimuth is not automatically upgradable, and so that's where the data is kept, because when you upgrade something, you throw away all its data. And so the events have mostly come from there, except for the transfer event. Although arguably we should use owner changed instead of transferred, just because to be this like parallel to the other ones that we're going to use. The only reason the transfer one exists is because it's ERC 721 required. And so we really shouldn't, since we have an equivalent one that's our own, we should probably just use that. I'll mark that as a to-do for now. Okay. Then, right, so then the other ones that we are going to need to respect is anything that affects our the state that we actually care about. So activated isn't real. Spawned is, I think, not really required. Man, maybe it is. It probably is. No, there's not that much we can do there's not that much we can do with it because we don't know who owns it once you run spawned. We should look at, so when spawned is emitted here, when it is, register a new spawned point for the prefix. Emit spawned, that's the only place it shows up in register spawned, but register spawned came from ecliptic. Register spawned we do here. If it's direct, we call set owner. If it's not direct, we also call set owner. Both of those if previous owner is equal to that. So if we didn't change the owner, we don't emit anything. But this is going to set the owner in both cases to something that's not 0. Then if we used to have a different owner, then rearrange the indices. That's a lot of burned gas that really doesn't need to be there, in my opinion. And then we say, okay, but that's an if, not an, there's no else on that. So there's no, right, so this is going to happen no matter what. Say rights, points owned by, points owner indices, emit owner changed. So we're going to get owner changed in any case. We don't need spawned then. Because we're going to get owner changed in anytime the owner changes, which, sounds right. Okay, so we're going to skip this. Escape requested, escape canceled. We might need to respect those. Escape requested. We are going to need to handle that, yeah. So escape requested is point sorry, not point, uint32 and uint32. Yeah. Okay, so that's one. Escape canceled we'll need. Every time I see canceled spelled with one L. Is it always spelled with one L? I feel like it's usually spelled with 2 L's, but I feel like it can probably actually be done both ways. I think I always do it 2 L's. Oh well. Okay. Escape canceled, of course, means you're no longer trying to escape. This is the archaic usage of the term canceled. Escape accepted is, we are going to need to handle that as well. Sorry, wait. Escape canceled is also UN32, UN32. Escape accepted, UN32, UN32. Okay. Remember, what I'm writing here is the thing that goes into the hash function, so it has to be exactly right, because I'm doing that according to the spec. I can't put names or something in here. It's just the types. Okay, then lost sponsor, we're also going to need to be able to handle. That's where the parent has disavowed you when you without, like, while you were still sponsored by them. Okay. Changed keys we'll need to handle. Changed keys, UN32, bytes 32, bytes 32, UN32, UN32. That's going to be a lot. We're going to need to handle broke continuity. So that's when you breach. UN32 for the ship name, and then the number of breaches. Oh, apparently you can only breach 4 billion times before it wraps around to the beginning. Change spawn proxy. We need to handle. We do handle that up here. Change transfer proxy. I'm actually going to do, because these are all data related, right? Where, as opposed to ownership related stuff, and so order wise, I'm going to do these up here. Right. So after spawn proxies, transfer proxy. Changed transfer proxy. UN32 address. Is that it? Yeah. And then management proxy. UN32 address. And then voting proxy. UN32 address. Yeah. All right, and then there's also changed DNS. DNS is a little bit undercooked as well as a system, but we do rely on it. And naive rollups is, if it's going to be a drop-in replacement, needs to be able to handle that. I'll put that down. Yeah, no, I'll put it. It's kind of in the miscellaneous category. I kind of like having data at the end. I also kind of like having miscellaneous at the end, but there's only one miscellaneous. No, okay, I'll do it here. Changed DNS. And that's going to be string, string, string. Strings are weird in Solidity. They're weird in every language, pretty much, so. Okay, now this obviously it's not going to give very nice first of all, that's more than 80. Basically I want this to parse. Okay. I think this will not mess up the tis or the ketsig. Actually, I mean, I can go ahead and just do the ketsig here. That's probably the other way you could do it is use the tall form of .tis, which might be better. This is fine. Okay. And everything else we want to do is, does this work? I think so. Yeah, there. Except that's at 82, so we'll do it this way. I know it's a placeholder, but 80 columns is, I mean, if you know, man's got to have principles. All right. I'll just do them all this way. All right. I think those are all the events here. Let's take a quick look at, I know now I'm putting it on the other side, oh well. At the types here to see if there's anything it could need to change that this doesn't give us the information for. Spawned is not real because we can get that from owner changed. Okay, so then so owner management voting transfer, life pass continuity sponsor, that can all get updated through these. I think that should be everything. I hope there's not some place that we change something and don't emit an event for it. That would suck. But it should be fine. Okay. To make that actually parse, we need that. This actually will always be a crash, or at least on some level a crash. Okay, so sigbar, it's going to be unknown log, and just give the whole log. It's not very big. Cool. Okay. That's the set of logs we need to implement. None of those are going to be very hard. They're all going to be actually quite easy. Could list the other stuff or just start implementing these. I'll go ahead and list the others. That way it can just be very mechanical after that. Okay, so the others is the things that the batch needs to support, right? So batch, right now the opcodes, the transactions we supported these two. We need to support basically all the public functions here, except probably not constructor, but maybe. No, we'll handle constructors separately if we want to do that. Okay, and we say public functions, I mean public functions that you write. Public functions that you read, I don't think we really need to implement. You can get that, like the state there is legible, and so you should get that out of the state. Okay, then these are read. In Solidity view means that it is it can't change the state, right? Real quickly, I'm gonna get some water. I'll be right back. Alrighty. Also turned a bunch of lights on because it's getting dark. We had a nice sunny day today after some rain and snow for a few days, so I have plenty of power in the batteries now. Alright. Okay, so here's the ones. Right, so these are read-only functions. We don't care about those. Don't care about those. They're important in something so general as Ethereum, because you need to be able to, you're basically specifying not quite how to index, but they're not really necessary, right? You can query from a node. Well, it didn't used to support this, but it does now. You can query a specific address from a node, and from this solidity code, you can tell where everything's going to be stored. That's all highly specified. It's actually a super interesting specification. The way that maps and stuff are implemented is super wonky, but it's pretty cool. But this is not a read-only function. It is safe transfer from, which we overload to have or not have this data argument. So safe transfer from is an ERC721 function, which we also use ourselves. So I'll implement it still, even though obviously on our own naive rollup, ERC721 is not the law of the land. So this version just passes off to the other version with null data, and safe transfer from says, right, so this is an ERC721 thing where basically what you do is when you call, so transfer from is a function that trying to remember the difference between transfer from and just transfer. I don't remember why it's called transfer from instead of transfer. I used to know this. I can tell you that what safe transfer from is doing is it just does a transfer from, which transfers the asset, and then if what it's transferring to is a smart contract, then it calls a particular function on it, the on ERC721 received function. And we give it the argument of who is sending it, or no, this is who sent the transaction, who previously owned the from to. Yeah, the point of safe transfer from basically is to specify everything in a ton of detail. So we hand this function the person who sent the transaction, the previous owner of this token, the token ID, which for us would just be the ship name, and then a piece of data that can be added to it, and we want to make sure that they respond in a particular way. The logic here is that you don't want to accidentally send a non-fungible token to a contract that can't support it. And so if there's a multi-sig wallet or something that maybe can't support ERC721 tokens, or an exchange sometimes their deposit addresses, in some cases, are contracts. If they don't support it, they need to either not handle that function or not return this special value. And so if they do that, then then the whole thing will crash and you won't end up performing the bad transfer. That is not something that is meaningful on layer 2 because we don't have generic smart contracts. So I'm going to skip that. I don't think that there's a need for that. Transfer from, we probably are going to want. Although all it's doing is just calling transfer point. Transfer from is another ERC 721 one, and it doesn't matter. The from and to, it's over specifying without a real need for it, I don't think. So transfer point's the one that we really want to implement. Similarly, approve is just set transfer proxy. Approve is the ERC 721 name. Set transfer proxy is our name for it. Okay, yeah. So what I'm doing for now, at least, is ignore these ERC 721 ones and just use our native functions for that. And I think that'll be fine. I don't think we're ever going to get any benefit from supporting ERC 721 names on the naive rollups, at least not without significant changes happening. And at that point, we can add them back in. It's not very much code. Better to keep the specification small and simple for now. Set approval for all is another ERC 721 thing, but I'm not sure that we have. Let's see. We have, we do have set operator. I don't know that we have an event for that, or a concept of it in naive rollups, or I don't know if anybody's ever used that. Okay, so set operator just sets that and it does not emit an event, whereas probably because we get the event from here. Ideally, we'd only have to listen to azimuth events and not ecliptic events, but it looks like if we want to support operators, then we're going to need to support ecliptic events. So operators, I don't even think Bridge supports them really right now, but that's where you say, you can kind of see it just from this line, you can guess. It's that you have some ownership address and it owns, 5 different ships, and you want to say, here's another address that can transfer any of those ships. And so it's like running set transfer proxy, but for all of those ships. And if you add more ships to that, if you add more ships to that address, then you need, then that, the operator can still control those. If we do want to support that, and it's kind of a nice feature, honestly, even though we don't use it. I don't know. In the spirit of tending toward keeping things the way they are, we actually would need another item in our state because it's indexed a different way, right? It's not, everything else is based on your ship. Operators would be a map of address to address, right? That's where it comes from here. They do it as address to bool because, but we can just do address to address, map of address to address. Actually, that's map of address to set of addresses. So you can have many operators. Well, that's interesting. Bool there is just saying whether it's true or not. Bools always default to false in Ethereum. All maps, by the way, also have that maps in Ethereum don't have a concept of this exists or not, because everything defaults to 0, and so and zeros are generally just like cheaper everywhere, and so you have to put a bool there to say basically if it's a 1, that means it exists. Otherwise, it doesn't. It's I forget what they call it. It's like the membership function. There's a math name for that kind of a function. But we can represent that just as map of address to set of address, and if something's not in that set, or if that set is empty or whatever, then that counts as though the bool is false. Map of A to B, map of A to set of B is the same as jug AB, so I'll write it that way. There's some nice functions go along with that, and it's, in my opinion, it's a pretty important like fundamental data structure. Jug is not a common name for it, of course, but it's what we call it in Ethereum. I actually don't know what a normal name for that would be. A map where the values are sets, but it's certainly something that exists commonly. We call them jugs. Okay, so jug address that gets us our operators. So set approval for all is something that is going to need to exist. It's going to be exactly what you expect it to be, which is just set it there. But that we need to implement. Okay, so now we have something we actually need to implement. We need to go find where we're implementing these. I'll write them here actually, and then that whathap will mint lost until we implement them all. So set operator, which is going to take an address or owner and operator and approved. Okay, see, here's another one that has a boolean. So set means that we're either setting or unsetting an operator, right? Approved, I'll call it add for now. Whether it's like add or remove. Okay. Sorry, it's actually set operator is what I call it on Azimuth, but here it's called set approval for all, and I should probably default to the one that would actually get called, like from the outside. So I'll call it set operator is a better name though. It'll be set operator. Who's gonna stop me? The ERC 721 police haven't even given us an infraction for the transfer event problem. All right. Okay. Get approval is a read-only function. Is approved for all is read-only. ERC 721 metadata interface. This is where you define the name is so that it can automatically show up in things like Etherscan. AZP. Who knew? I think it does show up on Etherscan as that sometimes. We deprecated the name points, except for in the contract code itself. But apparently it's in the symbol. It will end the name there. Nice. In fact, we also deprecated azimuth to some extent. I mean, it gets used basically as a technical term now, and not as a not marketing, but not as like when we talk about ships and stuff, we talk about them as Urbit ID and Urbit OS mostly, which I think is, I mean, it's clear, it makes sense. But when we're looking at it technically, I guess we still call it azimuth, so it's okay. Token URI. Oh yeah, forgot that existed. Wonder if it still does. Probably still does. We're going to skip that. That's more ERC 721 stuff that just doesn't matter for us. Configure keys. That's an important one. All right. Configure keys is how you set your keys, and it's also how you breach, because there's a flag called discontinuous. If that's true, then we do a breach at the same time. All right. So configure keys gets a ship. Encryption key is going to be a bytes 32. Let's just call them atoms for now. I think I might have names for this that are clear somewhere, but it's not the worst thing to actually just write all these out. Crypto version. Oh, okay. You can't do camel case. Crypto version and breach. I don't know whether it's a good idea to be renaming things like this, but I think this is fine. Keeps it clean and simple. Okay. Configure keys. That's obviously an important one. Spawn is already specified here. Do spawn is internal. We talked about that one before. Transfer point is right there. Escape. No, that's an important one. Should we call it from and to, or no, that's misleading. It's ship and new parent, basically. Sure. Okay, then cancel escape. Fully specified. Adopt. Yeah. The way that this knows which who's adopting, like the way it knows the new parent is that it's just the one that ship has specified is trying to escape to, which is fine. That works. Like, it's asymmetric in kind of an unusual way. You sort of would expect that either side could initiate the escape. You could offer to adopt someone, or you try to escape someone, but we don't do that right now. You start by trying to escape, and then they adopt you, and that's the way it is. I will be back in a second. Okay, then, right, so adopt, that's an important one. Reject. You could also just leave them hanging, but I think, or unless this also, because this is saying, yeah. This one's kind of optional, but it exists, so it'll exist, or at least until we do a pass of maybe cleaning this stuff up. Detach. That says I sort of assumed it would be called like disown or something, but fittingly it uses a more detached term. Okay, so detach as a sponsor stops functioning the point. Detach. This is really, in my opinion, not quite the best interface design. I think that you should really have to specify both in each case. It doesn't like basically ever make a difference, but this, for example, would be ambiguous. Not actually ambiguous, but well, I mean, ambiguous in some sense if you had two stars owned by the same Ethereum address, and you were trying to escape from one to the other, and then one of them sends a detach, and the other one like tries to accept it, and then it's really just going to matter what order those transactions are confirmed, because they all kind of assume that whoever owns it now, or whoever's the parent now is who you're talking about, or whoever you're trying to escape to now is who you're talking about. I don't know. It's not a big deal. It's I can't really imagine a practical case where that's going to matter, but and it's certainly not like sponsorship. If something does go wrong, you just send more transactions to fix it. It's not. There's no ownership there that that would be at risk if there were any any practical attacks on this, or even practical bugs that come out of it, even just for accidental stuff. So I'm not worried about it, but I don't know, if I was doing it now, I probably would specify both each time. Regardless, okay. Get spawn limit is read only. We probably will need to implement that. Man, I hate when I accidentally Control D out of a shell I was in. Oh well. Also, I can just do this because I don't need those shells really at the moment. Although I'll likely accidentally bring them back. But okay. Then get spawn limit, read only. I probably will need to implement it at some point, but I'm doing this I'm filling out the transaction types. So can escape 2 is read only. Set management proxy, that's a real one. Set management proxy ship address. Set spawn proxy. This one's unit 16 because not everyone can spawn. We'll just call them ship though and assert stuff. Okay. Set voting proxy. I don't know that we're actually going to implement voting here. Voting maybe should just be on the main. I don't know. Problem is, if you move galaxies onto the naive rollup, then they could still vote on documents, but you wouldn't actually be able to vote on upgrades to the ecliptic, like automatic upgrades to the ecliptic. You'd have to do sort of manual upgrades, and that kind of sucks. So we should probably not let people transfer. In fact, let me put that here. Disallow depositing Galaxy to the naive rollups, because you need to be able. I mean, yeah, just for mechanical reasons. And if you're a Galaxy owner, you're gonna have a hard time getting people's sympathy for paying transaction fees for now. Hopefully we can lift that restriction at some point, basically you would need to make the ecliptic up contract. You need to change it so that basically you would change ecliptic contracts through effectively something more like an OTA than through a well, sorry, not through an OTA. You would change ecliptic contracts, not through an OTA, by doing the vote here in the naive rollup, and then that would say, okay, here's a new address, and that's what starting from this block number, you should look at that one. But in order to do that, I don't know if Azimuth really is going to support not knowing where that where the ecliptic contract is. I have to think more about that. So anything we have to think too much about, we should just delay for later, because this is not going to be that hard to upgrade, and so it's more important to make it small and simple and correct, because upgrading is fine for fixing performance problems or adding features, like being able to support galaxies on the rollup, but it is not fine for fixing bugs. I mean, it can be used for that, but it's a bug can be bad before you upgrade it. Okay, so set voting proxy we will implement for the moment because it exists. Set transfer proxy. Ship address. All right. Then poll actions. So this is for voting, and we're not going to implement those for now. So that would be start upgrade poll, start document poll, cast upgrade vote, cast document vote. I'll bet like nobody else on Ethereum uses uint8s, but we do. Update upgrade poll. It just checks and see if it's gotten to a majority, because you can't set a timer. Because one of the rules with Galaxy votes is that after 30 days, you check and see if it's passed. And so if you call this after 30 days, then it'll find out the answer, whether it passed. Okay, then create Galaxy. That's all happening on L1. Set DNS domains. Again, it's a wonky system. If we are going to support it, did I put DNS in here? I did. Change DNS. If we want to support it, then basically it needs to go in here. So DNS, set DNS domains. DNS domains at 0. It's a wonky system. It's basically that. For the moment, I'll act as though we are going to support it. Probably should. The DNS domains are so we bootstrap. So the way you find any ship is you ultimately ask its galaxy or its star or whatever. But to find a star, you ask the galaxy, right? So you ask the galaxy, where is your kid? Or more specifically, you send a message to the galaxy and say, please give this to your kid. And they'll probably respond directly, and now you found each other and you're good. But that means you have to be able to know where all 256 galaxies are at any given time. And so the way we do that right now, for convenience, is we look up galaxy name dot, usually right, I think always right now, .urbit.org. So like za.urbit.org, or I think it's .urbit.org. or rel.urbit.org or whatever. And then it's at a particular port number. It's port 13337 plus the galaxy number. And so you always know where they are. The .urbit.org thing, of course, means that Tlon owns .urbit.org right now, and so we don't want it to be that if Tlon says this galaxy shouldn't exist, then it's nobody can find it because the DNS doesn't get set there, and so you could add. So the idea with this list of DNS things is you could have .urbit.org, you'd have you could have a few other DNS domains to look at it, and so that if those are spread out enough, everyone can find it. In my opinion, that's all just like that's it's just hung over from a holdover from the way that we used to do this stuff, and what we should actually do is there should just be another transaction here that galaxies can send that says set IP, basically. Except that, or even just make it so that, any individual galaxy can set their own DNS domain. And then you can upgrade that DNS domain. Okay. So the most straightforward way to do it would be just set your IP here. In fact, if you wanted, you could say not only galaxies have to do that, but galaxies have to do it, but then other people could do it. And if they do, then you don't even need to ask the galaxy because they're saying that they have a public IP address, and you could just send it, talk to them directly. The one problem with this, of course, is that set IP is would be a transaction. It would cost some gas. It's cheaper with naive rollups, but it still costs something. And especially if you're changing your IP relatively regularly, then that's not going to be great. Galaxies should have a static IP though. So what you could do is set it to set DNS, and then make that be, or probably set DNS or IP, where you say you can either set it to an IP directly or you set it to a DNS entry, and then you can upgrade that. Like you can change that, in the normal way, and that'd be cheap. That's probably the best solution. I mean, you could support ENS, you could support whatever you want there, right? That's what we really should do, but it's not a significant problem right now. Whenever it becomes, whenever Tlon decides to deperson a galaxy, even if this problem isn't solved, someone's just going to create a build of the runtime that says, if you're trying to talk to this galaxy, just go to this IP address or look up this DNS or whatever. And then everyone's going to use that because, or at least anyone who wants to talk to those people. So yeah. Anyways, not too worried about it. I'll just duplicate what's there for now, unless we come up with something better. The fact that there's only 3 DNS domains possible is weird. I'll duplicate it exactly for now until I get a better idea. Primary. Secondary. They call it tertiary? Yeah, nice. Okay. Modifiers. All right, so that's all the transactions we need to implement, I think. But yeah, basically we just need to implement these logs and these transactions. And that'll basically be it. I think. I don't remember when I started. Trying to decide whether I want to keep going. This has been useful for concentrating and for reviewing the whole design, basically. I feel pretty good about it. It shouldn't matter when I start it, but I can look this up. I don't know why Twitch doesn't tell you how long it's been. Oh, there, 2.5 hours. Some of those older ones are like 5 hours long on my streams. The next step is just implement this stuff. You know what? These look easy. I'm just going to implement a few of these. I probably won't get too far, and then whenever I get tired or hungry or whatever, I'll stop. All right. So change transfer proxy. Make sure that I know what that looks like. Change transfer proxy is going to come here. Okay, so what I actually want to have up mostly is sys lol. Sorry, not that. Azimuth types. Huh. I wonder if I should be using that. Where does that come? Like, did something use that? Do we have functions that can handle that? I don't think so. Let me grep real quick just to see whether, let's see. If I look up, we'll just do management proxy. Gaze handles it. libazimuth. That is that. Does this have... Is this? Dang. Maybe I should be using this instead of recreate. Or, well, maybe I should be using that. It depends to some extent on how much the standard library that it depends on, because I can't use big stuff. See, it's done in a very generic way, which is honestly kind of nice because it means that you don't have to do all this specifically. Because you would get, like, instead of doing this, you would do a big whathep of all of these guys. These diff point. Let me take a look at the ones that it supports, right? So it supports owner, which should be changed owner. Activated, which I don't need. Spawn, or sorry, actually looking at this order. Transfer proxy, it has management, voting, spawn. And then change DNS, it has up here. Escape requested. I think it takes escape requested and escape canceled and puts them both the same, right? Not that. What is this? Apply point diff. I didn't write this, did I? No, I think Palfun wrote this. some parts of it look kind of familiar, but then other parts, I think Palphon wrote this. It might be that I can pull a bunch of this stuff in, and it might be cleaner than whatever I just like hack up. The apply point diff thing is actually interesting, and I might want to depend on that. Yeah, so like here, escape requested, escape canceled, get merged into escape. That's fine. Lost sponsor goes into sponsor, right? That's interesting. Now, what what we could do is kick all that out of libnaive. So right now, we expect something to be formatted as event log, which means that's let's see, event log is defined. Sorry, where's that defined in lib Ethereum? If you can't tell, I usually do this at this is on a giant screen, so usually I'm looking at it about this size, so I can have like a gazillion windows open. So it's a little more awkward when it's zoomed in enough for people to read, but it works. I think that's about where it was. Let me see. That might still be too small. No, that's about where it was. Okay. Then if lib Ethereum, what was I looking at? Event log. Right. So right now I say you need to, before you even hand it to us, parse it to this level. Because what you get back when you request something from Geth is JSON, right? So you could hand it as JSON to libnaive, but then now libnaive has to have like JSON parsers in it, and that like that's bad, especially if it's JSON as text. So you say, okay, well, parse the JSON text into slush JSON. That's better, but then you probably want the JSON reparsers there to turn it into what's sort of actually there, and that feels wrong. And so maybe you just include it looking like this, which is generic to the point where it's just an event log. So event log is, I don't mean event log in the normal sense, where it's just a log. But if you're going that far, maybe you also parse it all the way to this point. Then the specification in here is much easier. But of course, the more that you put the specification in here, or sorry, like the more that you push outside of it, the more that you have to worry that if there's a bug in the code outside of the specification, well, because it's not actually outside of the specification, it's just outside of the executable specification, but there could still be a bug in it, right? If your code to turn into something like this drops certain events, then it's now no longer obvious how you should properly run the stream of events. What events should exist? Should be the ones that, like, you know, if for some reason there's a bug where the spawn proxy doesn't get set in certain circumstances, then like should you respect what's actually happening on chain, or should you respect, you know, the code that's parsing to this? And so generally you want that to be actually inside the specification to whatever degree you can, because that's the part that you're going to inspect closely and that everyone's going to agree on. Okay. So my gut says parsing JSON text is too much. Parsing slush JSON is also too much. Defining something that's like, here's an event log, because that's but part of this is you have to look at where the Ethereum specification ends, right? The Ethereum specification, I don't think that it requires every like that it specifies the exact JSON representation of event logs, although it might. What it definitely does specify is that each log has, if it's been mined, then it has a log index, a transaction hash, a block hash. Like it has each of these things. It even has a specification doesn't say it has removed, but everyone implements that. And it has a list of topics. And so that I'm comfortable just saying, okay, you need to take what you got from an Ethereum node and turn it into that. Do that on your own. Don't mess it up. But I'm not sure that I'm comfortable saying, and you also need to interpret them as like beyond that. It should be that whoever's running the spec, it's dumb enough, like it can handle this totally generically, but it doesn't know anything about azimuth specifically, so it shouldn't have like a list that looks like that. Okay, I'm pretty convinced of that. So that means that if we want to include this code, we need to do that actually in the specification. And so this doesn't depend on all that much. It does depend on decode topics. Which is either here or, no, it's in libethereum. I sort of feel like this is a wet gate. I sort of feel like wet gates shouldn't go in the spec, just because they're so wonky. I mean, on the other hand, the knock that's produced from wet gate is dead simple. Like that's not the painful part of wet gates is getting everything to compile properly. It's the types that are painful. The knock that's produced is sort of dead simple. That's the one virtue of wet gates is that because they are sort of restricted parametric polymorphism, the knock can't vary based on the types, and so maybe it's fine. But if your types are messed up, then you could introduce a bug, because it could look like you're doing something when you're actually doing something else. For the moment, I'm going to skip this, like meaning not use this existing stuff and try and do it direct for a couple reasons. One, if it turns out to be fairly clean, then I'll just use that. Two, it's worth re-implementing this stuff and seeing it, like anytime that I see, oh, there's a gotcha that I might have missed, or that we might have missed in the past, then check and see whether the other one handles it. And then that'll also give a sense of how messy is this going to be without using these nice functions. Yeah, I think that's the right choice. But good to know this stuff's here, and I might ask Palfun if there's more goodies here that we might want to use. There's a lot of good stuff here. These are the ones where those are just the contract addresses. These are the ones where I do it with a ketsig. Like that lost sponsor is equivalent to this, except the lost sponsor one. This one. Just want to look real quick at apply point diff. I wonder who uses that. Nobody does. Well, that makes it a little bit questionable then. Someone might have used it in the past. Okay. Cool. Cool. Then, if we are going to implement a couple of these, let's see. So we did transfer, except this should actually be changed owner or owner changed. So let me do that real quick. Owner changed. That'll also answer a question we had earlier, I believe. Okay, so this is going to be UN32 and then address. Okay, and both of these are indexed. It'll simplify some of this stuff, right? Okay, so as we no longer have a from address. We only have a to address and the ship. And so transferred ship is i.t.topics.event log. Kind of want to, I don't use log for anything else, right? Log is event log. Yeah. Yeah, that'll be cleaner. Okay. That feels so much better. It used to be i.t.topics.event log.input, and now it's i.t.topics.log. That feels correct. Okay. Transfer ship. We now no longer depend on it being in data or whatever because we don't use the RC721 log. We use the azimuth one. And we're also not parsing data, so yeah, we can get rid of that. Then we say, okay, from is used here, but we don't actually want from. What we want is owner.own dot. I don't actually know if this has this in its subject. Probably does not. And we need it now. So we will go back. We'll go to something that looks like okay, so to this point, azimuth types, and it's going to be this, and then we just say tis what owner.own. Okay, so if we're not depositing, then set it to the 2. Otherwise, leave it at where it is. Okay, that's at least it's clear, probably clear. It's not uncommon for when you see something that looks like this, that's just an unusual rune arrangement. It's not unusual for that to... Oops, I messed up my undo tree. Make sure I spelled that right. Owner.own.point. Cool. It's not unusual for that to collapse to more familiar ones as it gets massaged, because all code is basically the same, right? So okay. Cool. All right. I had a to-do, right? Yeah. Okay. Then changed transfer proxy. This should be easy. And it should be basically the same as change management proxy. and other related ones. So change transfer proxy happens just when the proxy is changed, as you would expect. And so what we're going to want is to parse two things out of it. Just say ship, I think, and then say we want to get existing state, although we don't care as much about it this time. Specifically, we don't care whether it exists. We're going to need a function that infers a default. Yeah, that's going to be... Yeah, let's build that. This get by state, and then like it produces a unit. Maybe it exists, maybe it doesn't. It's all kind of Mickey Mouse. And so let's make a helper function that says get ship we'll put it here. Get point. Yeah, get point. And it's going to take in state, or maybe points.state. You really should take in points.state, but it's easier to take in state. I'll take in state for now because point of a helper function is to help, but that'll probably get changed later. State and ship. What happened there? Okay, and then it's gonna be we're gonna get by points.state ship. And then I want to say if that's null, what sig existing. Obviously, I could be using fall in all these places, but I don't believe in fall. And also fall. So fall is a function that you give it a unit and a default, and if the unit is null, then it uses the default. Otherwise, it uses the content of the unit. First problem with it, of course, is that if calculating the default is expensive, you pay that cost regardless of whether you need it, which only sometimes applies, right? Sometimes it's cheap. And then the other thing is, I don't actually think it makes the code clearer. Putting in a senless fall is just like not actually clearer than what sigs, in my opinion. I know this is unpopular with a lot of people, but it's first of all not shorter, and second of all, it uses function calls which can do anything compared to whatsig, which can only do one thing. So I don't know, it feels better. Okay, whatsig existing. Then we do, actually this is going to be a little bit complicated. So if it does not exist, then, sorry, if it does exist, then we want to do just u.existing. Also, this is producing a, not just the point, actually it's point state, but we'll call it, yeah. And then if it does exist, sorry, if it does not exist in our map, then it implicitly is this, not that, point azimuth types, right? I think so. Yeah. Except that this part, of course, is more exciting. So, it's going to depend on, right? So if it doesn't exist, then the rule is, say, in terms of is it on L1 or L2, is if it doesn't exist in its galaxy, it's on L1. Everything should exist, but it's actually when this is, I mean, everything should exist now, but this is going to start from the beginning of time, right? So if it's a galaxy, it doesn't exist. Or sorry, then it's on L1 to start. If it's a star, then if it doesn't exist, then we want to check. Yeah. If it's a star, then it depends on its galaxy. Its prefix galaxy, right? So the if that galaxy is owned by L2 or has given its spawn stuff to L2, then the star is on L2. Now, we don't intend for galaxies to be able to exist on L2 at the moment, but we should still implement it that way. Because then the next level is planets. It's going to depend on their star. Okay, so that logic is fairly straightforward. We let me remember in what is it? Wherever title's at. Is it in Zeus? Or is it in Arvo? It's in Zeus. Interesting. Okay, so what we're gonna want to do is say clan in title. It gives so of ship. If that is equal to right is a what hep for or what less for now. We better not get comets or moons. I'm allergic to naked zaps though, so that's at least something. Sig bar. Okay. So if this is a czar, which is a galaxy, then what we want to say is this is just L1. It's on L1. If it's a king or a duke, these are old terms for galaxy, star, planet, moon, and comet. We keep them here because they're 4 letters, and that's really honestly convenient in the C. I'm trying to think if the C still uses any of this stuff. It probably does. It might, because you don't have to ref count anything that's 4 characters or smaller. You could, of course, abbreviate galaxies and such, but we don't abbreviate anything if we can possibly avoid it. Better to use a gibberish word than an abbreviated word, because at least a gibberish word you'll remember how it's spelt. Okay, so if it's a star, then this is also true if it's a duke. If it's which is a planet, then what we want to do is say existing. I should really change everything. It says existing to old. Existing is long and messes with the flow of everything. I might do that. Existing parent. Old is not right because it implies that it will change, and it may or may not. So we're gonna recurse, but set ship to the prefix parent of ship, and say, okay, we get that, and then we want dominion.existing parent At the moment, I'll just write it this way, although maybe that's kind of confusing. And so it's going to be, okay, so if your parent is on L1, then you are on L1. If your parent is on L2, then you are on L2. If your parent has designated spawning rights to the naive rollup, then you are on L2 because you hope to one day be one of its spawns. One of its spawn. I guess spawn can be plural. That looks correct. Cool. Okay. Let's use that everywhere. Everywhere I get by state, which would need to be point state anyways, because we added things to state other than points. Get by state. Okay, so this is get point state. Okay. Except I want to look at each of these cases. So it's just these three cases. Okay, so there's also this case and this case. Okay, let me actually not make the changes quite yet because I want to be able to catch each one because it's not a unit anymore. So each one of these got to change. Okay, so existing state. This, and since it's that, it can be this. Yeah. Okay. So this suggests, for example, if owner changed happened to something that we've never heard anything about, but whose parent is on layer 1, that should crash. Which is correct. Okay. Then here we no longer have whatsig. So it's just don't change it. Right? This is maybe better to write as a... Yeah, this whole thing is going to get a lot simpler, actually. Okay. I think we can do it as like a tis what? As we say, then dominion dot existing state, which should just be called point or something. But it is what it is for now. If that, then we want to set it to, okay, so if we're depositing, then we want to set it to L2. Otherwise, we want to leave it. Yeah. Yeah, exactly. We want to leave it at what it is. Okay, and then whatsig existing get. Yeah, no, get point infers it, but it doesn't have to save that. That's fine. Okay. So then tis what dominion dot existing state deposit address to and then here again existing state can't be null. That bunting happens already, and so we just have this, and then we want to say dot existing state existing state is so long. Old state. Here I will call it old state. Yeah, where I have it existing up there is not old, but here it is changing. Okay, so old state. Okay, so get point state transferred ship. Right, so tis what dominion.old state deposit address to. Let's line these up. So if we're depositing, then that goes to L2. If we're not depositing, that goes to 2. That's reasonably clean. Yeah, that's probably bad, but it's kind of tempting. I'm not going to do that. It's tempting. Ugh. I will do this. And yes, with a zap like that, I think it's fine. Okay. I should fix the syntax highlighting to highlight that, but it's kind of awkward to get that right. Okay, and so this is not point. This is old state. Yeah. Cool. Point state would be another possible name for it. Old state's fine for now. Okay. Cool. Then here we go and we say, okay, get point state. Can't be null. And so we say assert that. So if we're doing change spawn proxy, it needs to be on L1. If it's not on L1, then that just doesn't make any sense. And it's no longer a unit, so it's just this. Okay. Okay. Then again, can't have unit here. New point is just point.old state. So what we actually want is this. Yeah, we're already on L1. So if we're not depositing, just set the spawn proxy. Nothing more to it. If we are depositing, then we want to change it from L1 to spawn, and then we don't want to set the spawn proxy. So point dot old state. Alrighty then. That's significantly cleaner than it was. Sometimes you gotta get one of those low-level functions like get point, and then everything can be cleaner. All right, get by this one, but that's not done yet. Although I make it parse at least. Okay, here, get point state. Yeah, okay. Get point state. So point state now. We don't have to assert that anymore. We just assert this. Yeah, if it didn't exist, that's okay. That just means that its ownership address is going to be 0. And if you found a private key for the ownership address 0, then you are welcome to take all the anything you want, pretty much. Okay, so assert signer's owner transfer proxy. See, here I do call it point state. Really should do that because I can even do tis point state, I think. It doesn't need you anymore. In fact, given that, do we even need to? We refer to it a decent number of times. It's probably good to tis tar like that. Although tis calling on top of tis tar makes me really anxious. I think it's fine. Good enough for now, at least. Okay. The rest of this is gonna be fine. There's nothing to it except put by points dot. Yeah, those ones up there are not quite right. Put by points dot state ships dot tx point, but it's not point. It's L2 point. Yeah. Okay. Looking back up here, I don't think it's quite right. There's a close, but man. Hey, we have to do this, but now that our state has more than just points, we can't just produce that. Also, we can't do put by state anymore. Knew it was gonna come back to bite me that I tended to just refer to it as state instead of points.state. Okay, so then I could do this as send tis, but that introduces another init level of indentation, which is not really right. I'm tempted to use a tismic, which sort of inverts the flow of control, but it lets you then use wide form send tis, right? You get to say state where points. Honestly, people don't like this, but for something that simple, that's what I'm gonna do. At least for now. Okay. Then back to process transfer point, where we get to say, let's see, point, we set various things on it. I don't actually think that's going to work through the tis tar. You know what I'm kind of inclined to do, though? Is just take the face off of it. Nobody needs the face. Because I hate having to just refer through it when I just want to add something onto it, right? What if we just do this? And if you really need to refer to it, just use lust.pointState. How many times do we refer to that? See, it makes all this stuff so much easier. Less dot. It's okay. Yeah. We're just saying replace the head with that. I mean, that's fine. Don't like that? If you're allergic to Lark syntax, we can say, I mean, this is better, right? It's better than what we had before. I mean, look at that. Look at that symmetry. Oops. That's what you should be doing. All right, where else are we referring to this? We don't need that if we can just refer to point now as point state. Honestly, I kind of want to just call those points anyways. But for the moment, I'll... 81. I don't want to conflate... Like, because this is careful code, I don't want to conflate point and point state. No, but they are the same thing. The only reason why I think of them as separate is because we have a type in the standard library that talks about, like, that just doesn't have dominion in it. Really, that should be in that type. Okay, so point state is not a real thing. Point is the real thing. I'll slowly start massaging things into that. Yeah. Okay. Then owner.point, transfer proxies, owner.point. Yeah, that was incorrect before, but it's correct now. So net.point. Don't need that anymore because we know that it's L2 because we asserted it's L2. So, and it includes that. So there we are. All right. Did I finish that? Let's see. Make sure. This one's missing. Missing a dominion, anyways. L2. There we are. Okay. There was a couple layers. The refactor stack was a couple layers deep there. I think I finished all the refactoring I meant to do. But until you compile it the first time, it's fine to just have half-done refactors lying around because you'll catch it later. Okay. Process transfer point, get point. Start operating on that. No tiz tars anymore. Cool. Okay, process spawn, get by points dot state, get point state, send point. Oops, DFE, there we are. And this one needs to be send point anyways. Point. All right, but can't be null anymore. So, asserting it's this and that we can just do hep dot. Yeah, this one can just be hep dot as well. It's slightly cleaner that way. All right, so we assert that. Assert signer is owner or spawn proxy. Parent point at send point. Parent doesn't exist anymore. It's just send point. Probably should just be parent. Yeah. This one I gotta think about. Let me come back to that. Actually, yes, that's fine. Because get point doesn't insert it just because it looks at it. Yeah, that just means that it doesn't exist. That's fine. I think it's fine. Okay. My feet are getting cold. Okay. Has by points that state. Right. So we get to here. Parent still exists, still does its same thing. Do spawn is down here. Should probably just merge it right now. But what's happening here is put by points dot state, ship L2. That all actually looks correct. Did we assert? Where did we assert? Yeah, that one is correct. Okay, I think that's all correct. Let me just real quick then merge these ones. Let's see. Do spawn. So ship is ship.tx. 2 is 2.tx. Direct is this, and holder only exists in the one branch anyways, and is owner.own.parent. And so then we can just do this. Should be else comma, I wonder. Cool. Cool. Okay. All right. That was a good refactor. And I think this now should be really clean. It's no longer get by state. It is get point state. Disfaz old state. Which we get to call like point now. Let me refactor that slightly, because old state now is it can just be point. Makes it cleaner. It's definitely true, by the way, that the word point is overloaded everywhere way too much. Like that point is different than point azimuth types, is different than this point is different. I mean, in lull we have, let's see, we have those two just like right inside each other, but at least it saves it that way. Right, so there's those, but there's another one in like lib Ethereum or something, right? Or sorry, it wouldn't be an Ethereum, it'd be an azimuth. Yeah, there's another one here. Now that's within ETH type, but and then there's also another one in ETH noun. Now those are qualified, right? You're not actually gently going to run into them, but when you grep around for it, it's annoying to be like, is it this one? Well, maybe. It'd be okay if it was like, oh, this is an XY coordinate and this is azimuth stuff, but they're all azimuth stuff. Oh well. So just do a different number of P's in each one. One of them is point, another one's point, another one's point. Yeah, let's do that. That's a joke if anyone wants to, is looking to blast me over that. Old state here. Point. All right, then this is a point, and we don't. Well, I mean, it's better be on L1. We're gonna put the assertion in. Yeah, better be on L1. Except we can do hep.point. Slightly nicer style. Circumfix is, really for special occasions. Okay. then it's just, no effects, tis hep, state, points, hep, and then it's going to look a lot like this, except we're going to skip like nothing about depositing. And so honestly, it's just one line. Why not? And if it is one line, can we do that in one line? Should it not be one line? Is it? Let me get it right first and then think about whether it should be one line. Transfer proxy dot own, right? Yeah. Goes to 2. All right. Should it be that? Transferred ship should just be ship. Here as well. And here. Then, with it that small, then yeah. And then you just do state points. That's a bridge too far. We'll do this. I think that's reasonable. If it existed in isolation, TISHEP wouldn't be worth it. But because it exists as a pattern, I think it's better to use the TISHEP. Yeah, I think that's good. All right. Then we should be able to do manager proxy, voting proxy quite quickly because it's the same thing. The only difference, I think literally the only difference is that here it's management proxy and this voting proxy. Now, there's a temptation to abstract this because we have 7 lines that are the same lines and that are maybe not quite final and we might change one or another. It's probably a good impulse, but it's hard to do it really all that generically because, for these 3 functions, I don't know. There might be a way to, like, a lot of these have that ship and to thing, so you might be able to, I don't know, like pass in a callback that starts you off like here, which for these ones starting off there is starting off like here, right? And so and you could say that you don't have to produce the whole state, right? You get rid of that TISHEP by saying you only produce points.state. So then it would just be one line. That is probably worth doing. But I'm actually going to leave it for the moment because I like to err on the side of just laying the code out rather than abstracting it into functions, because it's always easier to abstract than to de-abstract. At least, yeah, actually, I think that is true. I'm not sure I've ever quite consciously thought of it that way, but I do think it's pretty much always easier to abstract than de-abstract. So cool. All right, then I think that'll work. We're up to 288 lines, which means in these 3.5 hours, we've written about 60 lines of code, 70. That's pretty good. And that doesn't leave that many of these, but they are going to work a little different. We have to think about how sponsorship works. So I think I'm going to leave those for another time, because I'm fading a little bit, which is weird. I shouldn't be. but oh well. Cool. Okay. Then yeah, I feel good about how that has worked out. I'll put this on a branch somewhere. Right now, it just exists on my machine, and we'll post. I don't know where I'll post it. I'll post in like the development channel of Urbit community. I'll post the branch name, but um, it'll be called like probably Philip/naive. It'll be the branch name. But yeah, okay. All right. Hopefully that made some sense. That was very useful for me to be able to talk through it all. If you have questions about this stuff, feel free to ask. Um, just ping me, like include my name. Like the questions can be in public. That's useful. But just use wikdev so that I get a notification on it. If you see a bug, obviously point that out to me as well. And yeah, let me know if there's any easy ways to make this streaming stuff more useful. I think I might have been bouncing the mic stand against the table during part of that. If there was a lot of click or whatever, I'll try not to do that in the future. But let me know if anything was weird about the sound of the video or anything like that. Yeah. All right. I will see you all later.